In a previous video, I showed the palindrome challenge. And in that challenge, I went through a bunch of different ways to figure it all out so that in the end, we could figure out whether Mom, Dr. Awkward, and Dogs Wear Pajamas were palindromes. And when we ran that, we found that Dogs Wear Pajamas was absolutely not. We did have to do a little bit of cleanup to get rid of the spaces and lowercase things, and in the end, this is where we left off. Now, in that video, I mentioned that there were some potential extra bonuses here where we could talk about things like accents, right? What happens when a word has an accent? Is it the same or is it different? And so today I want to explore that a little bit, even though some of this is going to be under really bad assumptions. And we'll talk about that in a second. So to start off, this is where we left off. We were taking that string, we were lowercasing it, we were replacing everything that was not a word character with an empty string. And then we were testing the reverse with the past tense string. So we were reversing it and then testing it to figure out whether it was true or false. And this works. There's nothing wrong with this. It doesn't quite work with accents though. So if we go here and we paste this in a couple times, and I grab my multiple cursors and I change this to, let's say, this one. So now it's got that accent on there that I think it's an umlaut if I remember correctly. Down here, I'm going to change this one as well to race car, like this. But the first A is going to be that same character, and the second A is going to be this one right here. So two completely different A's. This capital A from Dr. Awkward, very different from this one, but we're going to play around with this. And this is where our really bad assumption comes in. Because in most languages that have accents, the characters are different. Okay, and I want to say that right up front because this A, this base A, is very different than this accented A in pretty much every single language. But for today, I want to make the assumption that they are the same. I know that that's wrong. I want to make the assumption that they are the same just so that we can play with code. So put your pretend hats on with me and let's play around with this a little bit, okay? So if I run this right now, I'm going to clear this out, run it again. We're going to see that these two should not work, and yet this one does, okay? This first one is failing, or this first accented one is failing. The second one is not. And in order to see why, we need to see what this lowercase string is actually returning. So let's console log that out. Right here to lowercase string, just like this. Clear it out, run it again, and we get something very interesting, okay? When we look at this one, the accented one, right above it, you can see that it has gotten rid of that accented A. It's lowercased everything else, and in race car, it's gotten rid of both of those A's because they're both accented. So right now, our regular expression is kind of lying to us, right? It's saying that it's collecting all of those word characters, but it's not. In fact, this slash W is pretty much the same as going A to Z, A to Z, capital A to capital Z, and 0 to 9, okay? So it's grabbing only that selection of letters when we do that backslash capital W, and that's not what we want. Now we can fix this. We can use something called Unicode property escapes, which is a really fancy way of saying, go further, right? Go get the Unicode values, which extend out to 65,000 some odd characters. Just a ton. So we can do that really fast by going /p for property, I'm assuming, okay? And remember, capital P is the opposite of lowercase p. So when we say capital P, or the capital letter, in this case, capital P, we're saying, yes, I want everything that I'm about to do. And with the lowercase p, we're saying, I want everything except what I'm about to do, okay? So when we use this /p, we need curly braces in here, and we supply it with some sort of a range, okay? We do that just by typing it in as letter in this case, okay? There are plenty of others. There's one called diacritic, which is what these symbols are. So we could do something around there, but for us, we're really only concerned with things that we think, or that the system thinks, are letters. So none of the symbols, none of the arrows, none of the emojis, none of that, okay? Just letters. And if we run this again and clear this out, run it, we're going to see that it doesn't actually do anything. In fact, it breaks even more, okay? Because it's still returning that dot in that space, even though we only said letter. Part of that is because I knowingly ignored a letter here. So we need an extra flag. We have the global flag to pick up on every single one so that we don't have to add a star in there. But inside of here, we also want to add a U for Unicode. And now when we do this and clear this out, run it again, we get true, true, false, false, which is exactly what we would think, right? Because this A is not the same as this A. So technically, these are right. But we are going to go the other way in order to play around with some code, okay? This is where we start. Everything starts from here. If we don't have the right string, we can't move forward. So at this point, we're in really good shape to play with some other code. The first bit of code that I want to play with is something called normalize. And normalize basically takes these accented letters and pulls them apart, destructures them into their root letter and the accent. So I'm going to comment this out right here, and we're going to create a demo, okay? So const word equals, I actually want this accented word, this version of Dr. Awkward right here. And we're going to console log out something out. But first, I want to create a function, okay? This function is going to be called convert character, okay? Convert character code. That seems like a better one. And we're going to pass in the string, whatever the string is. Now, the function is going to return an array, okay? So we're going to spread that out, get that string, and then we are going to map over stuff. In there, where each part of the array is only going to be a letter. But the way that this works, it's a little bit funny. I'll show you what that looks like. So right here, we operate on that letter, and we get the character code at 0. Because character code is assuming a place along the string, kind of like the string is an array, because technically it's an array of letters, but let's not get into that. So we get the very first one, which is technically the only one. And if we do that, we should be able to console log this out. Whoops, right here for word. Now, let's make sure we do it right this time. Right here, word goes in and clear it out, run it, and we get 11 characters, which is how many letters are in Dr. Awkward, okay? You'll notice dr dot space accented A, 196. I can tell you that the base capital A is number 65, okay? But the way that this works, 196 is this whole accented letter, okay? We can change that by going with, by changing this, okay? We can change it by changing it. That didn't make any sense, but here we go. So right here, I'm going to change this by going word.normalize, okay? Normalize, again, it pulls that letter apart. It destructures it into its pieces. We need to pass something in. In this case, we're going to pass in something called NFD. And NFD does exactly that. It just destructures it into the root letter and whatever accent falls on top, okay? Copy and paste this, paste it down really fast, change this to norm. And what you're going to find when we run in this again is that we get 12 letters on our second one, okay? dr dot space A, there's our capital A. Remember I said it was 65. And then right after it is the accent. In fact, if we change this to character at instead of character code at and run this one more time, you're going to see that it gives us that accented A, and then down here it gives us the A and the accent. The accent is kind of hanging out weird because it tries to move it backwards onto the A, which is why there's no space in here, right? So it tries to bring it back, place it right on top of the A, which means that now we have everything we need to get this done, okay? So normalize will allow us to extract or decompose that accent. We can comment all of this out. Right between here, we're going to paste that in. It's going to be the exact same thing. And if I uncomment all of these and run it one more time, but not the last time, it should go true, 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 false, okay? Because now it's getting rid of the accents for us and only comparing the root letters, the A to the A, the A to the A. Again, not a true way of doing this, but it gives us a chance to play with the code, okay? In production, we have big questions. We really shouldn't be doing this way. For playing with the code, it's going to be okay, okay? The second thing I want to talk about today is, instead of normalize, I want to play with something called the INTL namespace. Sorry, not letter space, namespace. And the INTL namespace has a lot of power on it. It has things like segmenters and plural rules and date time formats, and all of these are designed to work with locales and internationalization. So you usually pass in your locale and it gives you very specific information related to that locale, okay? So same thing, I'm going to comment this part out for a moment. We're going to look at some other stuff. And I'm going to start by doing numbers, okay? So I have a number, const numbers, plural, equals an array. It's going to be 1, 20, 3, 100, 10, okay? Just all out of order. Doesn't even matter. And now down here, I'm going to console log that out. So console log numbers, okay? Just like this. Now, I do want to sort them before I forget. And if we sort these, logic says I should get 1, 3, 10, 20, 100. But if you've ever done this before, you know that that is absolutely not true. And what we end up getting is 1, 10, 120, 3, because 2 comes after 1. It doesn't care about the zeros. It only cares about the 1 and the 2 because it's an alphabetical sort. Normally, we would pass in a function in here, so A and B, and we would return either a negative number, a positive number, or a 0. 0 meaning leave it alone, don't touch it. It is because the letters are the same, okay? So A minus B, we run this again right here, and we get 1, 3, 10, 20, 100. Now, this works. It's very short. It's very easy to read. A lot of people understand it. But again, that's not what we're here for. We're here for the INTL namespace. So let's go and do that. We're going to go const num collator, because that's what we're going to create here. And it's going to be new intl, capitalization matters, collator, like this. And inside of here, we pass a locale, okay? In this case, English. Now we can totally use this. We can replace this function here with numcollator dot compare. There it is, dot compare. Compare is our test function. So it gets that A and B and returns either a negative number, a positive number, or a 0. If it's 0, remember, they are the same, okay? This is not going to work. In fact, it's going to revert back to our original one because, well, first off, I forgot a parentheses, so let's fix that. It's going to revert back to our first one because we haven't told it how to sort. We've only told it what language to sort in. So it's still sorting as alphabetical. We need to pass in some options. And right here we pass in numeric. Whoops, numeric. There it is. And set it to true. Now, when I run this, I'm right back to normal. It should go 1, 3, 10, 20, 100 because I'm sorting numerically, which is exactly what I want. There are tons of options in here. In fact, that's what we're going to use to create a brand new isPalindrome function. And what you're going to find is that it cleans a lot of this up. So right here, copy this commented out, bring it right down here, and now we can start to clean stuff up. First steps first, we need a new collator. So const collator equals new intl, whoops, collator, and pass in our language. That's very important here. And now we can use that. So everything starts to change in here. And what you'll find is that everything gets a lot more lean. Okay. So right here, I'm actually going to take this and move it right up here, just like this. I'm going to replace lowercase string with the string being passed in, okay? And at this point, we use our collator. So this whole string goes away, and we pass in collator. We left it outside of the function because we don't want to recreate it every time. So we get a little bit of memoization, right? A little bit of memory saving there. But right here, we are going to compare the string and the lowercase string, okay? Just like this. Hopefully I did that right. Let me check. Absolutely. In fact, lowercase string doesn't make sense because we aren't lowercasing anything, so we can change this to reverse string like this. And remember, it returns negative, positive, or 0. And what we want to check is if it's 0. If it's 0, it's the same, right? I've said that, I think that's my third time now. But if it's 0, it's the same. At this point, I can clear this, uncomment all of these, and run it, and it'll report wrong, okay? And the reason that it will report wrong is because, again, we haven't added any options, okay? So our first option is sensitivity, like this. Sensitivity's default is variant, which means any little change gets caught, okay? If there's any sort of difference, they are not the same. But in our case, we want to only test on the base, which means that this A's base is this, at least for English. We'll talk about that in a second, okay? This A's base is A, so we're going to test those. The other thing that we need is something for the dot and the space. Both of these fall under punctuation, so we can ignore punctuation like this. Whoops, spell it right. Hit true. And now we're only testing the base letters. We're ignoring the punctuation. We're reversing and joining things. And when we run this, we get true, 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 false. Okay. So a lot of power in here where we can pass in a few different options and we're able to get a comparison, okay? Based on the root, based on lowercase, we can actually change the sorting of different cases. So lots of different options in here that we can play with. To review, we've made a very poor assumption that this accented A is the same as this A. And we did that so that we could play with some tools. Now, the first thing that we had to do was we had to change our regex. And that's because in Unicode, the accents are way higher up in the Unicode's range. And the original regex that we had here only tested for the base letters, okay? Not enough to be useful, so we had to go and change that. We absolutely did, it works. And then we started playing with normalize. And normalize allows us to destructure or pull apart the different parts of this accented letter. So it separates it into the A and the accent, which means that now, when we do our replace all up here, it gets rid of those accents because it only cares about the letters. The accents are something else, okay? And then we took it a step further by looking at the INTL collator, and we were able to do some very interesting stuff around numbers. But for our use case, the cool thing is that we can pass in just a handful of options, and it just works. Sensitivity, by setting it to base, that also means that capital A and lowercase a are also the same. That's why you don't see that in here. But base ensures that even for capital letters, things work. For accented letters, things work. We ignored the punctuation and got it all done. And now we have this really robust solution for testing. Is it right? Probably not, because again, accented letters are technically different. And in fact, if I change this to Sweden like this, run it one more time, you're going to see that some things fail because those accents are very important in Sweden. So have good conversations when you use this, but it's a tool that we can use now, right? We can totally get into the collator and find new ways to sort and use that information. Any comments? Any concerns? Anything interesting that surprised you? Hit me up in the comments, and I will see you in the next one.